Okay, hi everyone, welcome to the new lesson. So today's lesson we will be entering into the chapter 5, which is also the last chapter in your statistic 1 syllabus, which is called as the normal distribution. Okay, so under this topic, right, you have actually 3 learning outcome to learn. So for today's and Friday's lesson, we'll be focusing on mainly like some of the basic skill that you need so that we can move on to the next 2 learning outcome in the next chapter. Okay, so it's going to be like a little bit confusing at the beginning because it's something that you never learned before, and it's going to be like a little bit like much more complicated than the discrete random variable that you have learned. But after you get a hang of the method and the process, then you will actually find out it's actually quite easy. Okay, it's just about the process, like it's a very step-by-step approach. Okay, all right. So before we move into the chapter, right, so for the chapter 4, what have you learned is you learned about discrete random variable, right? So discrete random variable is basically a random variable that you can take on like a certain value. So normally we talk about like x equals to 1, 2, 3, 4, 5 and so on. So those are discrete random variable that you take on only exact value, which is which is normally a countable value. Okay, so then under discrete random variable you learn 2 type of distribution, which is called as binomial distribution, and the second one is called as geometric distribution. Okay, then after that, for today's lesson we will be looking at the other type of random variable, which is called as continuous random variable. So if you still remember when I introduced chapter 4 to you guys, I also introduced something about random variable, and at that time I put in a little bit like what is the information about continuous random variable. So it's same like discrete random variable. It is a random variable also, but it can take on like all the value that lie in a certain interval. So normally we use continuous random variable to describe something that you need to measure. So like for example the weight or the height of the people. Okay, so under continuous distribution you have one type of there are a lot of distribution, but then for your S1 syllabus you are just going to learn one, which is called as normal distribution. So this will be our main focus for this chapter. Okay, all right. So I hope that you can understand. You can go through also the notes that I have written down here. Okay, so a normal distribution actually frequently occurs in the real world. For example, the height and the weight for the people. Okay, so I'm going to explain it like this. So I'm going to redraw this. It's okay, you do not need to redraw. I'm just going to use a very simple example to explain this. Okay, I'm just going to do something like this. Yeah, it's not exactly the same like the one in the note, but the idea is the same now. Okay, so maybe when we talk about height, okay, so in this example maybe I'm going to talk about height of 18 years old boy maybe. Okay, so when we talk about height of 18 years old boy, right, when I ask you, do you have like a average idea of like how tall is an 18 years old boy? You can see that normally they are like within 160 cm to 165. Then under this one, maybe I will have this one is like 160 to 165. So this is like the mode. You can realize like what I'm trying to say here is like maybe majority of the boy having this height, and in average is if I try to add up the taller one or the not so tall one together, then the average maybe I will get is like between 160 and 165 also. And you try to arrange all the boys together, and you will realize the midpoint of all the boys that you have together is probably going to fall into this group as well. Then what you can realize is like when you move on, right, you can see then this one maybe become 166 to 170. This might not be very actual in the real life. I'm just like trying to use an example to tell you. Okay, so when I move on to become higher and higher, do you think that the frequency of the boys like become higher and higher, so the frequency will become higher? No, like normally like majority of the boy having like an average height, then the taller and taller one you will get lesser and lesser. Then the same thing when we talk about shorter and shorter one, it will be lesser and lesser boy fall into that group also. So you can realize that as a data like this, right, after I draw a bar chart, I can realize that actually I can join everything together and it will become a normal distribution. Okay, so this is like a curve. So what you can see is like the majority or the average or like the midpoint actually stays in the middle. Then after that, what do I have? Then I have like two sides of infinity, because I can have like very short boy, then I can have like very tall boy as well. Okay, so this is what is that mean by normal distribution. Then this is not only applies for height, like maybe we talk about weight. Yeah, like the weight of the boys maybe like fall into a group of like 55 to 60. Then when the height getting heavier and heavier, it will be like lesser and lesser of the boy falls under the category. So the same thing like when we talk about a boy with like a very light weight, then it's going to be like lesser and lesser also. So this is what is that mean by normal distribution. Okay, so I hope that you can roughly grab the idea. Alright, okay, so now I'm going to talk about some properties or characteristics about normal distribution. Okay, so you need to write it yourself, because I think that I don't want you to like only hear, only listen to me. Okay, the first characteristic that you can realize for this curve, right, is it is a bell-shaped curve. Bell-shaped. So it's going to be like having a peak in the middle like that, which like majority or average or like your middle point is actually falls in the middle. Okay, then after that, what you can realize that is like you have the same mean, you have the same median, and you also have the same one more is the mode. Okay, so mean meaning like when you add up all the height of the boys, and when you divide by the quantity of the boys that you have, you might actually get the same answer as the midpoint of the boy and the height of the majority of the boys also. Okay, so where is this? So it's basically in the middle. So normally we will write it as mu, so meaning like the mean. Okay, so meaning like majority of the boy, or in average all the boy, or in when we try to arrange it, the middle point of the boy is going to drop at the middle here. Alright, so this is the second properties of it. Okay, then after that, the third one is what you can realize after I draw this line is going to be like symmetric. So this graph is a symmetrical graph. Okay, so meaning like the proportion for my left side and the proportion of my left side is actually the same. Okay, so it's a symmetrical graph. Then after that, you see, just now when we try to draw the bar graph, right, this is actually the frequency density. So if you still remember, when we use the frequency density and we times the group that we have, is basically equals to the probability. So the total area under the curve is basically equals to the total probability. So what is the proper total probability? So same as random variable, same as discrete random variable, in complete you have a probability of 1. So meaning that every people that I count, right, is going to be fall under this graph, which is like my 100%. So the total area is basically meaning the total probability, which is equals to 1. So since just now we say that this graph is symmetrical, meaning that on my left hand side is going to be like 50% of the people, on my right hand side is going to be like 50% of the people also. So when we look at it, then it will be like all the people fall under the, I don't know the infinity, maybe like the shortest one is like 100, then the highest one is like 200. This is just an example, and normally we don't have that number. So like everyone falls under this. So for 100 to like 200 centimeter is going to be like my complete probability, which is 1. So maybe 50% of the people falls under 160 cm, then 50% of the people fall beyond 160 cm. So this is basically what is that mean. Okay, so I also put out the notes. In practice, real life variable usually do not really match all the condition like perfectly. Like you cannot really find a set of data that match everything like so well that you can really like the mean, the median, and the mode is like totally the same. But maybe we can find like very it's like an approximation. So meaning like it's like roughly the same. Okay, so and the situation will normally just approximate to the normal distribution. So normal distribution might be the best fit of the set of the data. Okay, so since all the normal distribution, right, so all the data that can fit into normal distribution will have the same shape. So meaning that we can actually use one shape or like one distribution to find all the distribution that we want to find. Okay, if you cannot understand this part, it's totally fine. I'm going to explain it again when we talk about standardization. So, but then I'm just going to talk about standard normal distribution for today because you are going to learn how to read a standard normal distribution table. Okay, so this is a standard normal distribution. So what is the special thing about this distribution and the normal distribution that we have learned just now? Okay, so normal distribution have these four characteristics. So for standard normal distribution, it's going to have the same characteristic like a normal distribution also, but then they have two things special, which is the mean, which is the middle point right here. The mean and the median and the mode is going to be equals to 0, which is in the middle. And the other one is the variance is going to be like 1. Okay, it's like kind of like very hard for you to understand because actually the idea of like changing this one to this one, you actually need to do integration because you know like integration you need to find the area under the curve and so on. So but then it will be like a very tedious formula, like a very long one, so normally we don't use that to do. So in real life then no, like in normal life then we're trying to use something called standard normal distribution graph or table to help us to find all the value here. So it's alright that you don't understand what does that mean, but you just remember the mean will be equals to 0 and the variance is equals to 1. So I'm going to explain this further when we talk about standardization. So for today's lesson, right, we'll be starting with the basic skill like how to read probability from a standard normal distribution table. Okay, so you do not today's lesson it won't be involving like the real data set or like the modeling. It's basically about reading the table and understand how to draw the curve. Okay, alright, so later we'll be moving into the table part. Okay, so please flip to your last page of your handout. So I have attached the normal distribution table for you. So I purposely put it as the last page so you can take it out. So for every lesson for this chapter, you will be using this table as well. Okay, so alright, so in before we move into how to read the normal distribution and how to calculate the probability, I'm going to make some brief introduction about this table first. Okay, so actually there are a lot of type of normal distribution table. So this is actually just one of it. So this is the table that will be used in your A-level external exam. So I'm going to teach using this one. Okay, so in the introduction you can see that if Z has a normal distribution with mean equals to 0 and the variance equals to 1, which is what we talked about the standard normal distribution just now, and for every value of Z, the table gives the value of phi Z. So you can see like a symbol that you never see before. So this symbol is actually called as phi in maths. So it's actually just an unknown, so you can just like treat it as a function just like that, and it's a function that you are going to describe this table. Okay, it's basically just like that. Okay, so I'm going to introduce to you something about your curve first before we move into how to read. Okay, so you see just now we say that for every normal distribution, right, you have a bell-shaped curve like this, and you have your mean in the middle, and this mean is 0. Okay, so for like the common sense that you know, or like from the table, the what is that called, the number line that you know, if this is basically like my y-axis in the middle, because this is like my 0. If I'm going to label a negative number, where I will be labeling? I'll be labeling on my left hand side, meaning all this value will be a negative value. Correct? So meaning what I'm going to label here is definitely going to be a negative because it's on my left hand side of my 0. Then everything that I'm going to label on my right hand side is going to be a positive number because it's on my right hand side of my 0. Okay, so now with this normal distribution graph, right, actually what you are reading all the positive z-score. So z-score is basically like your random variable. So meaning that the graph will not show you anything that label on your left hand side. The graph only show you all the positive value here, and it's going to be less than z only. So you cannot read anything that, okay, maybe this is my z. Okay, so the table will read for you the value that is smaller than z. It will not give you anything that is greater than z. So meaning that if I'm talking about phi 1, meaning that what I am trying to read from the table is basically meaning that this is my 0, right? Then maybe this is my 1. I mean, of course, this is not the accurate one, but I know that 1 is definitely on my right hand side. So when I read about phi 1, what do I get is basically the area under the curve less than 1. If I'm trying to read phi 1 2.728, it also means that I have this bell-shaped curve. My 0 is in the middle, 2.728, and what I am getting from the table is what is the area under the curve that is before 2.728, meaning like everything to your left hand side only, and you can't read anything negative from your table. Okay? So you just remember what you are learning, what you are reading from the table is all positive z value. You can't read negative from your table. And then what are you going to read is basically the area under the curve that is like the probability lesser than the z that you are trying to find. Okay? So I'm just talking about the distribution. I mean, of course, we are going to find the negative one by using some methods later. So I'm now just trying to teach you how to read. Okay, so now let's look at some of the example. Okay, you do not have this in your handout, so I assume you to look at the video or look at your worksheet and try to find it together with me. Okay, because it's just like a very quick process. I just want to teach you how to read. Okay, so now we'll be looking at how to read the distribution table. So this is the exactly same table in your handout. I'm just printing it a little bit bigger so you can see, you can look at it like much more clearer. Okay, alright, so you can see this table, right? You have all kind of value here. Okay, so if you still remember in your discrete random variable, you have something like, normally what you are finding is like px equals to r. Then you have your r, then you have your number for your probability, right? Okay, it's the same thing in your normal distribution. But then for normal distribution, is because it's not discrete, so like you do not have like exactly x equals to 1, x equals to 2. So it's going to be like a continuous data. So in discrete random variable, it's not going to be equals to. It's normally like greater than, bigger than, and so on. Okay, so you are going to have the same thing. P, maybe here I'll put smaller because that's what is that mean in your curve, equals to this, and then it's going to be phi r equals to what? Okay, so when you look at this, right, okay, in your table, what is that outside is basically your random variable, which is your r here. Okay, so like in your discrete random variable, is basically your x equals to 1, 2, 3, 4, 5. It's like those value 1, 2, 3, 4, 5. But since it's not discrete now, so it becomes something that you have decimal here. Then the probability that you are going to have by formula in your discrete random variable now is going to be reading from the table. So what is inside the table here is going to be your probability. If I'm putting it in the curve that I explained just now, right? So meaning that what I am having as label is my Z, which is basically my R here, which is the number that I'm going to read outside. Then after that, the area under the curve, which is before my Z, is going to be what I'm going to read inside. Okay, so we will be like looking at some example together, and I'm going to draw it out so you can understand it better. Okay, number one, when you have phi 0.3. Okay, so now look at your table. Find 0.3 starting from here. Okay, so you have 0.3. Can you find that? 0.3. Okay, so after you find 0.3, what does that mean by phi 0.3? It's basically 0.30, correct? So 0.30, then you find 0. I'm sorry, I moved the calculator. I hope that is still clear. Okay. Yeah. Alright. So for 0.3, then you are looking at 0.30. So this is 0.3 and your 0 is here. So meaning that what is phi 0.3? It's basically 0.30, which is 0.6179. What is that mean by 0.6179? It's basically meaning that if I'm going to draw the normal distribution, right? Okay, then I'm going to have something like this. So meaning, since this is 0, right, then of course 0.6179 is going to be at my right hand side of the 0. So I will have like my 0.3 here. So 0.3 is what I will be labeling. So what does that mean by 0.6179? It's basically the area smaller than 0.3, which is here. This area is 0.6179, and basically this area is the probability. Is that okay? Alright, yeah, so 0.3 is the Z value that you have, meaning is the value here. Then the answer that you get from your table is the area under the curve before 0.3, lesser than 0.3. Okay, now move on to the second one, 1.15. So same thing from your table, 1.1, you find it, 1.1 here. Then after that 5, then you look at here, 5, 1.1, then 5. So you are looking at this number. So 0.8749. Is that okay? 1.1, then 5. So 0.8749. So you have your graph. How will it be look like? Then it will be like this. Same thing, 0. So you imagine if 0.3 is here, then maybe 1.15 is here. It will be like much more further than 0.3, right? So after that, I'm going to shade the area before 1.15 also, and this area is going to be 0.8749. And is that correct? Yes. You see, when you compare to the first one, because you are shading for a larger area now, meaning the probability become larger also. So you have an answer that is actually greater than the first one. Alright, okay, now move on to the next one, 2.37. So same thing, you find 2.3 here, 2.3, then 7. So 0.9911. Is that okay? 0.3, then 7. So 0.9911. So what does that mean? It means that when I try to draw the graph, then 2.37, it will be even further than 0. So it will be something like here. So 2.37. So what does that mean? The area under the curve before 2.37 is 0.9911. Is that correct? Yeah. It's the largest among the three because the area that you shaded is actually become bigger. Okay? So now you have learned like the basic one. Then what is the usage for this one? So you see, just now we deal like for 1 decimal place, 2 decimal place. Now we move on to the 3 decimal place. Okay, so I'm not going to draw this anymore. I hope that you can understand what are you finding and what is that mean by the value here and the value here. Okay, so now 0.783, how do you find that? So 0.78, you already know how to find. So 0.7, then 8 is here. So that's why you have 0.7823. So how about the 3 here? So what are you going to do? So 0.78, then the third number, you are going to look at the last column here. So 3, so you find 3, and you see 9, and you see the word here add. So what does that mean by add? Are you going to add 9 inside the number? Yes, but you are not going to add 9. You are going to add 9 at the last place of your number. So meaning that if this is 0.7823, you are going to write 9 at the last place, at the end. So meaning this is the 9. And you plus them together. So what does that mean? Meaning that you are actually adding 0.0009. So this is equals to 0.0009. And you need to plus them together, which gives you an answer 0.7832. Is that okay? Alright, so now we look at the following example again. 1.377. Okay, so find 1.3. Okay, you can get 1.3, right? Then after that, 7. 1.37 is here. So 0.9147. Okay, 1.37. Then you have the last 7. Then you look at the 7 here. Okay, which gives you 11. So how do you do with the 11? 91747. So you must remember 11 must be placed at the last place. So 11. So it's going to mean 0.0011. So plus 0.0011, which will give you 0.9158. Okay, after you get it familiar, of course you don't need to write this anymore. I'm just trying to illustrate to you what does that mean by the last place. Alright, okay, I hope that I can get it. 1.37, 0.9147, and you see 7 is 11, so meaning you are going to add 0.0011. Okay, the last one we do together, 2.239. So 2.239. Okay, so look at 2.2 first and 3. So you get the number of 9871. Okay, 2, 3. Then after that, what's the last number? 9. So you look at this 9, it brings you to 3. You are still looking at the same row, okay? So the 3 here. So what does that mean by 3? 0.0003. And you try to add up together, then you get 0.9874. Okay? I hope you get what does that mean by the table now. So meaning exactly what you are finding here is like all the probability that is like lesser than the exact value that you are finding. Okay? So I hope that you can read. Then now we are looking into like the probability part. So you must make sure that you know how to read, then only you can move on for the question. Alright. Okay, so now we'll be looking at the important part, which is the focus on this lesson. So you see you only have 2 types of questions here, which I want you to really understand what does that mean before we move on to like the opposite one for tomorrow. So I don't want to make you like very confused. Okay, number 1. So if Z is a normal distribution that distributed in a normal distribution with a mean of 0 and a variance of 1, find all this value. Okay, alright, so what you have here is like you must remember the probability of your z-score is basically equals to the area under your graph. And for continuous random variable, there is no difference between the sign whether you have a equal to or not equal to. Because the idea is like the number that you are going to take is like a range. So when we talk about z smaller or equal to 1.62, right, it's basically the same thing when we talk about smaller than 1.62 without the equal sign. Because you do not have an exact value like discrete random variable that we say like smaller than. Then we say smaller than 3, it means 1, 2, 3 is not included because that is discrete. But now when you talk about, okay, for example, if I talk about like z greater than or equal to 1.62, then what is the number that I should get? I can take 1.622, I can take 1.63, and so on, because it's like continuous and you can get any number inside your interval, so that makes no difference in the sign. So meaning whether you have equal to or no equal to, you are going to do the exactly same thing. You just care about whether it's less than or more than, that's it. Alright? Okay, so in the process later, you might feel a little bit confusing, but make sure that you understand the whole process. Please do not memorize. Okay, so you understand how to draw, you understand what I'm talking, then you should able to do it like using your understanding without like what is that called? Without memorize the method. Okay, so now we are moving into 1a. Okay, probability for z smaller or equal to 1.62. So how can we find that? Then we move into the first thing that you might need to know is how to sketch your graph first. Okay, so let's try to sketch it. We start with the number 1, which is very easy lah. Okay, so you need to sketch it with me in your paper so you can understand at least for the first time. Okay, so you remember, draw a bell-shaped graph. So make sure that the two ends doesn't touch your x-axis. Then you have one in the middle. Okay, then sorry, you have a line in the middle, then it's going to be 0. Okay, 1.62, where are you going to label it? So 1.62 is basically a positive number, correct? So that's why you can draw anywhere, it's totally fine. You don't need to use your ruler to measure or what. So just draw anything, but it must be in the same, it must be at the correct side. So meaning 1.62, you cannot draw it in your left hand side, okay? So 1.62. So I'm going to draw like this, okay? Or you just draw a line, it's okay. Okay, then after that, this is z smaller than 1.62, meaning that what is the probability for your random variable that is smaller or equals to 1.62. So I'm going to label, or I'm going to shade my area. It's going to be like the area here. Okay, so this is my area that I will need to find now. Okay, so you remember just now when we do the phi, right? What does that mean? It's actually mean everything smaller by. So that's why probability z smaller or equal to 1.62 is basically the same thing with phi 1.62. Is that okay? If you still remember the exercise that we do just now, what is phi mean? Phi mean like you find the z value and everything that is less than. So that's why you have like 1.62. So that's why you are finding the exactly same thing. I'm just going to use this lah. Okay, so 1.62. So you are going to find it in your table, 1.62. So 1.6 and after that 2. So it's going to be like 0.9474. So what does that mean? It's basically meaning like the area that you shaded here is equals to 0.9474. Okay, so in words, it actually means that in a standard normal distribution, the probability that for you to get a random variable that is smaller than 1.62, the probability is 0.9474. Is that okay? I repeat again. For a normal distribution, which is standard, which have a mean of 0 and variance 1, the probability for you to get a random variable that is smaller or equal to 1.62 is 0.9474. Okay, that is what is that mean. So we are going to put it into a real life situation or like application in the future, but you are just going to know how to draw and how to find first. Okay, move on to B. So we are going to draw it again. So now it's like greater or equal to 2.033. So I'm going to draw like this. Same thing. Okay, so 2.033 is going to be right hand side also, right? So put anywhere. Okay, now is the random variable greater or equal to 2.033? Are you still going to shade it on your left hand side? No, you can't, because this is greater than. So it now become here. Is that okay? Alright, now problem come. You see, you cannot find anything that is greater than in your table. You remember? Just now, everything that we find show us the area that is lesser than. So now if you have a question that you need to find probability more than, then how do you do that? You still remember one of your characteristic of normal distribution? The total area under the curve will be equals to the complete probability, which is 1. So how do you find that? Instead of finding more than, then what I'm going to do is I'm going to use a complete graph. Okay, so I'm going to use a complete graph to minus. I only can find less than, right? Then I will find the other part, 2.033. So instead of finding here, I'm finding here, because I cannot read that in the table that given. So that's why I'm using the full probability, which is 1 minus the part that I can find. So that's why probability for z greater than 2.033 is going to be equals to 1 minus probability for z that is less than 2.033. Can you get that? Yeah, I hope that you can get that. I mean, it's very hard for me like to really know that whether you understand it or not, but yeah, try to get it lah. Yeah. Okay, so basically from the table you only can find the value that is less than. So for anything that is more than, you need to use some method to find that. So since you only can read less than from your table, so I'm going to, since you want to find the area here, so I'm going to use 1 to minus the area that is less than, so I get the more than. Okay, so it will be equals to 1 minus, so this is probability z smaller than 2.33 already, then now you can change it to 5 already. In other words, you can remember, as long as you look at your table, right, you see something like this. Phi z equals to probability z smaller than z. So before you actually reach the step that you have z smaller than z, you cannot change it into phi, that meaning you cannot read it from your table, just like that. Okay, so now I change it already. So phi 2.033, then I'm going to read it 2.0, then 3 and 3. Okay, so I write here 1 minus, then 0.2.03 is going to give me 0.9788, and I'm going to plus the last 3 here, which is 1. So plus 0.0001. Okay, so I will plus them together, 0.9789, which by using my calculator I should able to get an answer of 0.0211. Okay, so which is, what is the 0.0211 mean? It means for a normal distribution with a mean of 0 and a variance of 1, the probability for me to get a random variable that is greater or equals to 2.033 is 0.0211. Okay, alright, move to C. Okay, now you see I'm trying to put in all the scenario for you so we can like explain everything like in a short, then when you look at the question you won't find it like confusing. Okay, so I'm putting it all like all the possible scenario that you might have. Okay, so for C, probability for z greater than negative 1.378. So same thing, I'm going to draw it first. Okay, so you see now you have a negative value. So where should you label your negative z value? So it's going to be at your left hand side because it's negative. So this is the negative 1.738, and this is greater than, so meaning is here. Okay, alright, so now I'm sorry I'm keep changing my color of my pen. Okay, so now the same thing, you see you cannot find more than, and of course in your table you do not have anything that you can read a negative value. So what do you need to do? So now again, from the characteristic that we have learned just now, we say that the graph is symmetrical. So meaning the proportion of left and right is the same. So if I have a symmetrical graph, it means that if I'm going to do a reflection for this graph, what will happen? I will get something like this. After I do a reflection, it will be like here, and I shade here. So this number now will become what? 1.7380, which is a positive value. And the area that I want to find is basically less than already. Then now I can continue with my working. Is that okay? Because it's symmetrical, after I do a reflection, then I will get something like this. Because it's symmetrical, so I reflect, then I get 1.727380, and I move the whole area like reflected. Okay? So it means that probability for Z greater than negative 1.378 will be equals to the probability when your Z is less than 1.378. Okay, 1.378. Is that okay? Sorry, I write the wrong number. 1.378. Is that okay? So the probability that is greater than negative 1.378 is equals to the probability that is less than positive 1.378. Then now you have Z lesser than already, then you can write in 5 already lah. So equals to 5, 1.378. Then you can read from your table 1.37, which gives you 0.9147. You are going to plus the 8, which is 0.0013. So after you plus them together, you will get 0.9160. Okay, then that will be your answer. Alright, okay, move on to D. So same thing, we are going to draw the curve first. Okay, same thing, bell shape. In the middle, you have 0. So this is negative. So you are going to draw it at your left hand side also. Negative 1.328. Now this is lesser than. Okay, again, this is lesser than, which is what we can find in the table, but this is a negative value. The Z score that we can find in the table is only the positive one. So what should we do for a negative one? Try to think. Okay, so what do you need to do is you need to do 1 minus again. So I'm going to change it so it becomes the exactly same thing like my B. So I'm going to do reflection as well. After I do reflection, what do I get? So you imagine now this line will be reflected to the right hand side that I'll get here 1.328. Then the shaded region now will become here. So you see this is exactly the same thing like your B now. So what are you going to do? You are going to use the complete one to minus the less than area that you can actually find. Is that okay? After you do the reflection, then after that you realize that you can use 1 to minus the area that you don't want. Okay? So meaning probability for Z smaller than negative 1.328. It will be equals to 1 minus probability for Z smaller than 1.328. So I'm going to put it 1 minus. So in this case, then you can write in 5. So 1.328. So it will be equals to 1 minus. So same thing, 1.3 to 0.9066 and plus 8, 0.0013. So it will give you 1 minus 0.9079. Okay, which will give you an answer of 0.0921. Okay, I hope that you can understand everything like step by step. Then so basically when you try to draw the first one, then you will be able to know what is your next step. Okay, so now we are looking at few more example together. Okay, move on for the next 4 example. Probability between 0.9 and 1.6. Okay, so same thing, we need to draw the graph first. Start with a bell shape. Oh, I draw it too big. It's okay. So I have a graph like this, then after that, where is my 0.9? So it's going to be like maybe somewhere here. Okay, so 1.6, it will be like even further than 0, right? So maybe here is like my 1.6. So I want to find the probability for random variable between 0.9 and 1.6. So it's like somewhere here. Is that okay? So this is the area that I want to find. So how do I find that? Okay, so for this one, it's actually quite easy. Yeah, so if you still remember what is the principle of this one, then you can realize that what you can do is you find out the phi for 1.6, meaning you get all the area here less than 1.6. Then you use phi 0.9 to find all the area here. Then you use the big one minus the small one, then you will get your answer. So basically you are using 1.6, okay, to minus, sorry, I forget and I draw it too big. Okay, and you need to minus the 0.9 that you have, so which is the area here. Okay, so meaning probability for Z in between 0.9 and 1.6, it will be equals to probability for Z lesser than 1.6 minus the probability Z lesser than 0.9. Okay, then we change it to phi. So phi 1.6 minus phi 0.9. So you can get the value from your table. So 1.6 give you 0.9452 minus 0.9, which is 0.8159. Okay, so when you minus them, then you will get an answer of 0.1293. Okay, alright, move on to F. Okay, so probability that in between, so now is 2 negative number. Okay, so first thing, same one. Let's try to draw the bell curve first. Bell shape. Okay, 0 in the middle. So which one should be nearer to 0.18? Nearer to your 0, it should be this one, right? So Z is greater than this one, smaller than this one, so this number is bigger, so that's why it's like here. So negative 0.185. Then you have the other number, which is like maybe somewhere here. Okay, negative 1.183. Okay, then you have, this is the area that you want to find. So the Z between 1.183 and negative 1.185. Okay, so now, how can you find that? So you see, you are in a negative region again. So you remember just now in ABCD, when you have negative region, what do? You do reflection. So same thing, you are going to reflect them. So I'm going to reflect it, but you must remember when you reflect it, right, this one will be reflected nearer to here also. Like this line will be reflected to here. So that's why you have like one line here, which is 0.185. Then you have the other line here, which is 1.183, which is correct lah. I mean, the bigger the number, the further the number from 0, right? So this is the area. Then now you see it's the same thing like for your number 1 already. Then you can use the method that you used just now, which is you find the bigger area for 1.183, the whole thing here. Then you use to minus the one that you have here, 0.185, which is all over here. Okay, so probability negative 1.183 Z is going to be equal to, so probability Z smaller than 1.183. If you want to put this also can, if not, it's totally fine. Then minus P Z smaller than 0.185. Okay, so it will be equals to phi 1.183 minus 5, 0.185. Then now you can try to read from your table. So 1.183, 1.183. Okay, actually after you get the idea of how to use the table, right, if you don't want to try to, you just want to add it in your calculator and you write your answer, is totally fine also. Meaning that what I am doing usually is like 1.1, then 8. So I see this number, then I look at the 3, then I know that I need to plus 6, then I know that my answer is 0.8816, like that. So it's not necessary for you to really write it down, but it's just like sometimes when you do mental calculation, there might be like some mistake, some, what is that called, careless mistake or so what, so you can just write it. But if you can like straight away find it, then it's totally fine also. Okay, minus 0.185, so 0.18, then 5, I'm going to plus 20, so 18, so it's going to be 0.57 plus 20, so 34. Okay, is that alright? Okay, then I'll be writing my answer here, which is this will be equals to, okay, so when I plus them together, then I'll be getting, can you try to find it okay, let me grab my calculator, hold on. Okay, so I have 0.8816 minus 0.5734. So I have 0.3082. Okay, so that will be my answer, 185. Okay, alright, so move on to the next one. Okay, so probability for Z in between negative 1.222 and smaller than 1.738. Same thing, start with drawing your graph. So, okay, now one negative, one positive. 1.222 and the positive one is at 1.738. I'm going to shade in the middle. Okay, so this, how do I find that? Okay, so you can see one very obvious one that is very easy for you to find is the number here. So since that this is like here, then the region that you want is basically smaller than 1.738, then you can straight away find the area under 1.738 already. But the problem is with the negative one. Then what do you need to do? Okay, so maybe you can try to write down first the first thing that you already can do. So meaning that I'm going to use the probability that is lesser than 1.738, which is the whole thing here. I'm going to minus, how am I finding the small region here? So you see, I'm going to do reflection again. So meaning when I try to reflect this, right, meaning the small area that I want to get is basically the small area that I want to get here if I'm trying to reflect that. So how am I trying to find that? Then meaning that I'm trying to use the complete graph again to minus the part that is lesser than that, so I can get this small area to minus, which is 1.222. Can you get that? Okay, so meaning that I'm going to use this part, the whole area here, to minus the small part here. So I cannot find the small part here because it's negative side. Then I'm going to do reflection to get me here. So after I get me here, then I use the complete graph to minus the area that I have for everything for my less than part. Then I'm going to use that to minus. So what I'm going to do is probability for negative 1.222 Z 1.738 is going to be equals to, then I use this one, probability Z smaller than 1.738. Okay, then I minus 1 minus probability for Z lesser than 1.222. Okay, so this will be equals to 5, 1.738, and then minus 1 minus 5, 1.222. Then I can read from the table. So 1.738, 1.7 738. So meaning I have 0.9538. So I'm going to plus 7. So plus 7 here. Then I have 8, 9. Okay, then I'm going to minus 1 minus, so 5.1.222. 1.22 give me 0.888. Then after I'm going to plus, I am going to get 0.8892. Okay, so I use my calculator, then I'll be getting 0.9589 minus 0.11808, which will give me 0.8481. Is that okay? Alright, so move on for the last part. So for z modulus greater than 0.845. So if you still remember, modulus basically meaning like you change the negative to positive, then positive remain positive. That's what modulus mean. So meaning here you can accept like 2z. One is positive one and one is negative one. Okay, that means that the thing that you already know is like z. For a positive z, it will be greater than 0.845. That's for sure. Then the other one is negative z. So since you do negative z, then your, what is that called? Your sign is going to change because you times your z with negative. So it will become like this. Is that okay? So meaning like, of course I need to have, okay, after I draw it, then you will understand. So modulus z greater than 0.45. So meaning that it must be like 0.845 greater than, okay, so you imagine now this negative number, after you modulus, the value that you get is greater than 0.845. So the number must be like, okay, for example, should I take negative 1 or I take negative 0.5? If I get negative 0.5, after I modulus it, I get 0.5, which is not greater than 0.845. Then I should take negative 1, correct? So I am going to shade here instead of greater than. Can you get what I mean? Okay, so meaning that any value that is going to be smaller than negative 0.845, after I put the modulus, is going to be greater than 0.845. Like for example, all the value here is like negative 1, negative 2, negative 3, and so on. So all this value after I modulus, then I will get greater than 0.845. If I'm shading here, that means that something like negative 0.2, but negative 0.2 after I put modulus, it doesn't give me a value that is greater than 0.845. Okay? Alright. So, okay, maybe I try to draw the other one, so if you cannot understand, then you just remember. But I think this is not so popular in your standard, so it's totally fine. I'm just like teaching you so you can understand. So yeah, what is more important is like the in front part. So this is like in case. Okay, so modulus z, if it's lesser. If it's lesser, right, then this is very easy there. Then you are just going to do like this. You are going to do inside one. Okay? Bigger than you are going to do outside. It's the same thing like quadratic. You just remember modulus z, then you can do like z squared greater than, then meaning you are having like, this is not a very good approach, but just for your understanding, okay? So modulus z, you are going to learn this in your P3. So you can solve it in square, so meaning like greater than this one, meaning that in your quadratic, right, greater than, so you are going to do it like this. So this is negative 0.845, so 0.845, and you are doing it like outside. So if you are solving z smaller than this one, so in your quadratic graph, it's going to be like in middle because smaller than. So negative 0.845 and 0.845. So meaning anything between this range, after you modulus it, you should get a value that is smaller than this one. Which is like, for example, in this range, I can accept like negative 0.5. So negative 0.5 is here, right? So which is satisfied for this range. So you see negative 0.5, after I put it here, when I put modulus, then my negative is gone, then I left with 0.5. So 0.5 smaller than 0.45. 845, yes, correct. Okay, so just like that. So for this one, we are going to solve for this. So how are you going to find that? How? Okay, so you need to, okay, you have two choices here. First thing is solve like this one, then you are going to use 1 minus. So meaning that this one is find inside, then I can find inside, then I use 1 minus to minus the outside. But it will be like very long. So what is the thing that is very special here is like they have the same value here. And you must remember the characteristic of a normal distribution graph. They have symmetrical. So meaning that the area under here and the area under here is actually the same. Because it's symmetric, right? So since this is 0.845, after I reflect, it's going to be negative 0.845. So the area that I'm going to shade is exactly the same. So meaning the area here and the area here is basically the same thing. Then meaning that I'm going to find only one, then I times with 2, then I get my answer. So how do I get that? So which one is easier to find? Then of course I'll choose for the positive one because I don't want to do reflection. So if I want to find this area, then how do I do that? Then you use 1 minus. So you cannot find more than, so you are going to use 1 minus to minus the part that you don't want. So meaning what I'm trying to do is I want to find the area here, which is 0.845. Then I'm going to use a full area to minus the area that is lesser than, I drew it wrongly, that is lesser than 0.845. Then I get this answer, then I'm going to times 2, then I get here and here. Okay, so it means that I use the other color, it seems like so messy here. Okay, probability for Z modulus greater than 0.845, okay, is going to be equals to probability that Z smaller than 0.845 or Z greater than 0.845. Sorry, this is negative. Okay, I'm explaining the picture that I draw. Then after that, then I can start to do this. So what I'm going to do, I'm going to use 1 minus probability Z smaller than 0.845. So after I times it, then I'm going to multiply with 2 because I have two shaded region here which is exactly the same. So 1 minus, I have this, so I can find my phi. The whole thing, 0.845. Okay, so same thing, reading 0.845 for 0.7995 plus 514, then I will get 0.8 okay, maybe I write down 1 minus 0.7995 plus 0.0014. Okay, the whole thing I'm going to times 2. Okay, so I will be getting straight away use my calculator, then I'm using 2 to multiply by 0.1991, which I'll get my answer 0.3982. Okay, so I hope that you can really understand everything. So please try to understand, do not memorize. I mean, of course you can find a rule, and I can definitely like come up with a rule that asks you to memorize. If you see negative, then what should you do? If you have more than, then what should you do? But you see, there's like so many different scenario. Are you going to like memorize everything for your exam? So it's like unlikely, so it's like pretty impossible lah. So please try to understand everything, and make sure that after you draw the graph, then you know what are you going to do next, and it will be much more helpful to you. Okay, so I hope that you can really understand everything. If not, then I'll see you on tomorrow consultation hour. Alright, thank you. And please don't end the video yet. I'm going to teach you guys how to use calculator to do that. Okay.